attention is all you need.
I guess I have one comment. Could we put up the slide for Cerulean? So we didn't use like an attention-based model for this project, but something I'm excited about, like an application of attention for computer vision, is we have this problem with every computer vision model we're using pretty much is based on convolutional neural nets, and those are very, very memory intensive. So what we commonly do when we want to run training or inference is we chip up our images, right, into like 512 by 512, or even smaller sometimes if we want like a larger batch size. But the objects that we're trying to detect, if you're doing objects detection or segmentation, span multiple chips. And so there's a lot of inaccuracies there during that are introduced during training. There's all this post-processing you have to do on after inference. For this project, we actually ran inference on like 2 different overlapping grids, doing a ton of extra computation to be able to like get a whole slick imaged with our model. And so I'm excited about attention, and that from what I understand of it, I don't understand everything about attention, but that possibly it's a more memory efficient way representing like features where the model is like paying attention to like where like an object might be, rather than over like the whole Sentinel-1 like GRD. Yeah, I'm excited to learn more and see where folks get in the next couple of years in that area.
Can I add it? I think it's really good if you want to decode, if you have 100 pixels and 80% of your pixel is some sort of you're going to output the meaningful result for you. It's not super useful for this kind of like when you input 100 pixel, but your result is only going to occupy like 2 or 3. So I'm not sure. We can discuss more, and it's just gonna go into the weed.
I'd love to have this conversation later. So I want to go back to a comment about leveraging the wisdom of experts. A lot of the times, one of the most common fallacies that we commit in computer science is to say, "Stand back, world. We're gonna save this problem with algorithms." How do you avoid this tech fallacy in your work?
I think a very important part of avoiding that fallacy is being honest about what your algorithm cannot do. You really want to be proud of the model that you've produced and point out how accurate it is and show all the examples of where it performs really, really well. But it's also important to show where it doesn't perform well, especially when we're working with people in governments and organizations that are trying to help people, and they don't have time to put your algorithms to the test. It's important to show them this is where you can use it and this is where it's not going to be helpful, and maybe you need to come up with another method for those cases that's not ML or falling into that tech fallacy.
Yeah, go on.
Yeah, so I think it's definitely super important to acknowledge that machine learning is not magic. You can't have like one regional model and expect it to like inference anywhere in the world with similar performance. But some things that I know a lot of the people on this panel have also worked with is kind of the concept of like active learning and human in the loop machine learning, where you can kind of get your first inference down and then have a human go through and like relabel predictions and then have that iterative process improve the model. Of like a year ago, there was a collaboration between DevSeed and Microsoft for a land use land cover mapping platform called Pearl that ran in the browser, and the user could add a class that the model didn't originally learn and kind of tailor the model to their specific needs iteratively, and like keeping their expertise as part of this process. And like the model is essentially overfit to their area, but it's like becomes useful to them.
So that was a way to distill the wisdom of
I think when it's come to output the machine learning result, it's I'm talking about like serving the data layer to the products. It's very important to, one is like Martha said, like has human in the loop to verify your result. Probably is not looping back to retrain the model, but is so it's just like trying to integrate your machine learning into the products that you can shorten the feedback loop. So I think like shorten the feedback loop is the key. Either you getting feedback from your colleagues, like who is on the testing or validation side, who is like holding device, go to the fields to verify the result, or like who is on the client side. For example, our model is serving to a tool called MRV, like measure a report and verification. So farmer is on the other side of our API, so they can verify our results. If our machine learning result get really shitty, then like our manager will freak out first, and then client wouldn't be very happy with it. So I think it's very important for us to embedding the idea of like doing machine learning is not just like R&D, but it's like you are feeding the data layer to server products and serve like surveys or needs actually on the ground.
I remember that machine learning course on Coursera of Andrew Wing. There was one course, at one point he said, maybe you should just go back and clean the data more. You're going to get more bang for your buck, as opposed to like trying a fancier model.
Exactly.
So back to data, I want to ask, we've seen so many new awesome data sets that are big, diverse, and accurate annotation. What kind of tooling does it take? What kind of skills does it take to create a data set like that?
Yeah, it takes quite a lot of thought and I think testing, depending on the problem. So for the problem of oil slick detection, we were annotating on top of Sentinel-1 GRDs, and we needed to annotate on top of the whole image. We didn't want to chip this up before annotating because that was going to take a long time for annotators just to page through like more images. It's better if they can annotate the whole image at once. But that's a problem because a lot of annotation software, just complains when you try to feed it like a very large image. And sometimes the drawing tools like freeze up if you're trying to annotate on something too large. So this is a problem I think we need to solve. But yeah, it takes a lot of testing to make sure that your annotation software can actually get the job done and that you can annotate a sample in, hopefully in under 5 minutes. But when you're working with large images and complex objects for annotating, that can sometimes be difficult. So it does take a lot of communication between the data team that is doing the annotation. We have an in-house data team that the ML engineers work really closely with to try to optimize that workflow of getting samples annotated quickly. And it looks different for each project, each detection type.
Carolyn, specifically you, I'm really curious to know your experience with these data challenges. Is it just tools that get the job done, or?
Well, so when we got started working with RAMP, we obviously had a really huge data annotation problem labeling buildings, and the RAMP data set covers a lot of different areas over the world. And we went looking for a tool that would allow us to annotate rapidly. And we didn't find it. We found plenty of cloud-based tools. We wanted a tool that we could use locally on people's desktops. We didn't have a huge computer infrastructure. Most people were just dealing with their Macs or their Windows laptops or something like that. So I actually put out sort of put out a call and said, does anybody know of a lightweight tool that we can use this way? Nobody did. So this very basic tool that lets you just roll through chips, accept or reject them, and edit them as you need to, as far as we can tell, didn't exist. So we built one, and it's now out on DevGlobal's GitHub repository.
Yeah, I saw it, the chip.
The Chippy Checker. Yeah. So it's named after Chubby Checker. So yeah, it's the Chippy Checker. So we developed that tool, and frankly, we used it a great deal throughout the rest of the project. So we were outsourcing our labeling to Takada and via Radiant Foundation. And so we had an extensive review process when we got things back, and we worked very hard to actually the architect of this is in the audience, Seamus Garrity. We worked very hard to make the labeling process as consistent as we possibly could. In the end, I think one takeaway I took from the RAMP project is that is if you're really annotating over a large area, a lot of different areas, it's really almost impossible to get an entire team labeling consistently, not only because everybody has their own points of view, but because some of these areas just require local knowledge that nobody has. So if I were to go into another project where I was trying to do a very large, very diverse data labeling task like this, I would really try to find a way to set up a network of local labelers who are really familiar with the individual areas, so they aren't looking at, for example, something that looks to us in the West like a foundation that's covered with moss but is actually housing people. So really, the machine learning aspects of RAMP, in my opinion, are fairly straightforward. It is not a research project. It's designed to be a tool that people in country can use with relatively little underlying tools. No internet connectivity really required if you have your own server, and basically all you need is an NVIDIA GPU. We've made the requirements in terms of both knowledge and infrastructure as minimal as we felt we could. The magic in the RAMP project, we had eyes on it before and after. I mean, I believe we had eyes on pretty much any of our tier 1 data sets that are now up on the Radiant Earth Foundation. We had eyeballs on every single chip. So does that answer your question?
It does, yeah.
Yeah.
And I do have to applaud the effort that went into the documentation and the fact that you've added model and data cards. That really sets a high standard as to data curation and model curation and math observation. And it's very useful for my project as well, so thank you very much for that. I want to go back a little bit to the end of the whole model pipeline, a data model pipeline, and when it comes to model consumption and how users use it and how they perceive it. How can a machine learning model know what it doesn't know? How can any tools in your experience that can help with the calibration of uncertainty, the quantification of uncertainty? Where does uncertainty creep into the whole pipeline? Who wants to start? Brian?
Yeah, it might help to show like an example of like what is a metric that doesn't really show that. If you go to the slide with the confusion matrix on it. So like this confusion matrix that you're looking at is showing you like how many true labels of infraslick were actually detected as infraslick, or how many of those true labels were detected as some other class. This is all for like a particular confidence score of the model. So we like say some cutoff, like 0.5 or like 0.8, and then this represents like how the model did for that confidence score. So I think folks, like what often gets, I think, left out of like an ML project is like really closely examining like how your model results change based on that confidence score. So I think like just like maybe the simplest thing to do to account for model uncertainty is like look at lots of confusion matrices curve that like plots you know, how well your model did in terms of capturing true positives or like not having false positives, and like plotting that on a curve and that shows like how the model did in terms of different confidence scores. It's really good to do that. It takes time to engineer that for like different detection types and you know, each project, but it's good to do. I'd say like that's like maybe my first thoughts of how I would address that.
Yeah, thanks.
So as a, you know, sort of from a mathematical, statistical point of view, my immediate go-to, now I know there are a lot of, you know, different sort of speculative technologies that are out there. I've read a bit on Bayesian neural nets. Yeah, it doesn't seem to me that, you know, having a prior for every single one of your gazillion parameters is really a workable solution for a working machine learning engineer. But it seems to me that one thing you might do is perturb, in some sense, perturb your data set and look at how slight perturbations in your data set, or, you know, slight perturbations of other sorts might produce variance for your,
Like an augmentation, for instance.
for example, if you, yeah, just, you know, running several times with different augmentations, how much variability do you get on individual predictions? I would think that you could probably do that with you know, minimal additional infrastructure and compute on at least a subset of your data. And that would give you a sort of ad hoc idea of how much uncertainty. I'll bet there are tools out there for this, but if I were just rolling my own, which is what I tend to do, that's what I'd try.
You tend to do that a lot, don't you?
Yeah. It comes from, yeah, I mean, the advent of various tools that do all this stuff, it is very new.
That's actually a good point. It does bring up the trade-off between you know, the steep learning curve and new tool versus just adapting what you already know.
Mm-hmm. Yeah, I mean, when I got started in this business, there wasn't a whole bunch. I still tend to operate that way, although I do try new tools. Lots of times I find I get blocked pretty quickly and have to go roll my own.
Yeah.
Can we keep talking about uncertainty?
Absolutely. Yes.
Cool. Can we go to our general uncertainty slide, please? We have a fun slide to make everyone passionate. Uncertainty. Perfect. Cool. So you can have uncertainty like different points in your model. One way sometimes some of the models we work with, the input to a model is actually the output of another model. Like for example, we'll be making canopy height models, and it's really important. Those are pixel based, and each pixel will have a height value, but also associated with that pixel is an uncertainty value. And that's super crucial because that model is the input to another model that's eventually trying to determine project level emissions, which relate to issuance. We're in the carbon credit land, and the goal is to have a carbon credit truly be meaningful for a climate benefit. And right now, existing projects have baselines, but that baseline is just one number. There's no uncertainty metric associated with it. And that's why there's like a lot of issues currently in the carbon market, and something we're trying to address. So we're trying to bring baselines to the carbon market that have uncertainty associated with the emission values. And we're doing that by making, within an area, making fake placebo projects and running the baseline so you can get a value and you can compare the observed emissions to the predicted emissions. And if you have these like 100 placebo projects or however many you need, And then you can start to get upper bounds on your error and present a confidence interval that shows if for the project you're predicting emissions, it could really be between like 70 more context to benefit.
Are you advocating for making, when you're using model outputs as inputs for another model, are you advocating for using uncertainty as an additional feature or using it to determine like model input weights?
We would kind of use the uncertainty to further expand the uncertainty of like the final model's output.
So the way we address it in our model output, similar to what Martha said, our machine learning model output usually is input to another model. In our case, it's like we have a simulation model to based on fuel management, crop performance, and nitrogen inputs, and you can sort of like, simulate science. I think this is like a peer review, probably like published like 20 years ago. It's nitrogen and carbon sequestration and carbon CO2 emission model. So what we did is also like just provide the uncertainty matrix to the model input. And another thing is, I think like it's kind of like a blessing for agriculture, sort of research or ML type of problem, because USDA have a huge crop data layer. So we were able to output our, like for example, crop type maps for US, and then we can map against CDL from USDA and produce like sort of like pixel level, like what we actually get wrong. So we were able to just like field level, like what is your data consistency score? That's one thing, and that can serve as uncertainty score as well. And then the second layer is like you can rank your crop type, like what you actually get wrong. The third layer is you can tell like, what crops get confused to another crops, and how do we address it like in the training data set, or how do we adjust the weight input to the model. So there's a different way of addressing it, and I think like you should separate them to a client side, right? Like what our downstream application is our client, and how do we improve it in the model. So there's always like model way to address like uncertainty, and also like a client side to address model uncertainty.
Anything else? Okay. Is there anyone who would like to the audience? Okay, we've got 2 people. Anyone else? 3. Okay. Yeah. When do we start taking questions?
Is it working? Okay. So something I'm curious about is within research, within competitions, a lot of time there's a lot of iteration on the model, but the data is frozen. I think when you're working on reapplications, there's a lot of iteration on the data. And I think I saw somebody have the data version control tool up, that DVC tool, which I found useful also. So I'm curious about what sort of techniques have worked for you when iterating on the data, whether it's checking the label quality as it's coming in, detecting label shift, discarding labels. Techniques have worked with iterating on the data.
Something that's useful for me is when I'm comparing those model outputs. Obviously, your model outputs are not going to be perfect, especially for like an initial model where you haven't done much hyperparameter tuning or anything like that. But sometimes you see that your model is predicting things that actually make more sense than the labels that you're putting in. And so that's a starting point a lot of times for us to go back to our labelers and point out things that maybe they could do better the next time around. Or if we're doing our own labeling, we can fix it ourselves. Especially with land use land cover, it's easy to get certain classes confused because they look really similar to the human eye, but then the model is seeing a bunch of different spectral bands, and it might be able to make better classifications than a human labeler could.
I think to agriculture, the most useful tool or beautiful to look at is like data studio of Google. It's just like you can visualize like what your data distribution actually look like. And also you can see the real distribution on the map. So I think that's really useful. You want to, when you take care of the data iteration, you want your model, your input to be geospatially diverse and also representative of your real world use cases. And yeah, I found it like data studio visualization is just like super helpful.
Sorry.
Hi, I have two more questions about data. The first question is about OpenStreetMap as a source of global crowdsourced data with local knowledge that you could contribute back to. You know, how have you potentially used OpenStreetMap as input data or as a starting point for creating input data? And the second question is focused on sensor fusion and the benefits that you've seen in your work when going beyond, let's say, RGB optical imagery to bringing in not only more bands, but other sources of input, 3D data, SAR, et cetera. Thanks.
I love OpenStreetMap. I think it's a really invaluable resource for us building ML models, especially if you're trying to adapt it to larger regions or even the globe, in our case at I/O. But I think the most value I've found in OpenStreetMap is using it to filter for the image samples that I want to train on or do further labeling on. I don't think a lot of times you can use OpenStreetMap as direct labels. You can use it as maybe a starting point for your data labeling and then have a human labeler go and clean up those labels for the source imagery that you're using as your input.
Yeah, the unfortunate thing with, in my opinion, with OpenStreetMap is that its like goal is to record things like time dimension to a lot of these labels. That seek to do that, but yeah, on our side, I think we found the tooling around OpenStreetMap really valuable for creating data. So we use OSMC. Development Seed, I think, maintains this project. Other folks at Development Seed know way more about it than me, but it's an internal database that you can use to store annotations, and then we can use tools like JOSM, like Java OpenStreetMap editor, which is actually a really, really powerful annotation tool, and we use OSMC to store those annotations and organize everything, and that works out pretty well. So yeah, on the data creation side, I love it. On like the actually using the labels on OpenStreetMap, I think it's like, yeah, a starting point, but definitely requires validation.
And I think there was a second part of the question was around data fusion, fusion of products, different sensors. Anything you want to add on that?
Tricky. Yeah, we for the Cerulean project, you know, we we're working with a data set that was in a stack catalog, but our client had like resampled it and saved it as PNGs, and so we ended up not using stack. We also had to assemble this with other raster layers that represented like infrastructure locations and shipping vessel traffic, GPS coordinates, and rasterizing that. And so you're working with these data sets that are all in different standards, and it is difficult to assemble them. I'm a big proponent of when you can using stack catalogs and using tools that work well with that, and getting things into like the X-rate data model when you can afford to. But there are many projects we work with where the data sets are all over the place, and that is a little more difficult. But in terms of like what do you actually do and how do you represent data sets that come from different sensors, my rule of thumb is to give the machine learning model like the raw sensor data, the surface reflectance. You don't necessarily need to come up with your own features. Like I think the good first pass to do is like give it the raw bands for radar, like VV and then RGB or NIR. No need to come up with your own index. Ideally, that's something that the model should learn on its own as like one of the first features.
You want to go next?
Yes, this is actually a good follow-on question based on what Ryan just said. And so there's a lot of really great software out there for doing machine learning. It probably doesn't come as a surprise that I think that software is best when it's built around standards rather than building just like a one-off tool. By building up ecosystems of these things that are built around specs and standards. So the question is, what do we need in the ML region here for specifications like probably centered and expanding upon stack or stack extensions? What's needed to improve interoperability? And I know there's efforts. There's some ongoing efforts with ML Hub. But what do we need to do here?
I think we're always going to have a different tool. There's no, like we're solving a different science question and also like a products question, right? And it's just meant to be like we will have a different tool. But I agree with you that, like something like a stack it's just like a center. So that's something like we're trying to build is it's just like one thing is for ML, like we do need to versionize our model, right? Like this model, like we have to train like model to ecoregion because that is how crop types works. It's just like you can't do state-based, county-based, country-based. You have to do ecoregion, for example, and then you have to versionize. And I agree that like we do need to have some sort of like model card. And it should be metadata. It should be searchable. Like when you come to the country, this certain region, you should just like pull out the model, run the first set of prediction, and once you know the problem, right? Like you can map against the official data. Once you know that where to improve, then you can further go down to the rabbit hole, right? Like we always do that. Yeah, I don't think like we will have a single tools to solve the ML problem.
So at Impact Observatory, we use Stack to keep track of all of our data sets that we store in the cloud. And I think it's really common to use Stack across the community, or it's becoming a lot more common to use Stack across the community to store data sets. But I think it's also useful for model versioning as well. So if we can work together as a community to develop like stronger standards within that Stack framework for model versioning and also making your models more searchable, I think that would be really helpful.
Yeah, I think there was another question. No, you good? So, okay, I mean, we heard yesterday about the rise of Stack and how it can help us index and curate Earth observation data. I think also someone might have touched on the versioning, indexing, and the curation models, but also their outputs, because in the end of the day, the model's output is a product. How can we adapt what we already have for data, but for models? Perhaps like the stack. Is there some kind of direction going for indexing models as well? Yeah.
Like Radiant Earth is like kind of leading the charge on the ML Hub. And what I value about ML Hub is that it is trying to make like the model where it's like possible. Like Carolyn's model is up there and there's a Docker image so other people can reproduce the results and it's tied back to the input data. And I think that's super valuable. That's just like not possible for every use case. But I think the tooling is striving to aim for reproducibility starting from the input data sets all the way to the trained model to its predictions. And that's a good start.
I shouldn't dismiss John Duckworth, like who is coming from Radiant Earth Foundation to join WeGrow, and he is already starting to build like a central universe WeGrow database for us. And I think at the company level, organization is very good to use Stack to search like what data layer you have available in what geolocation and from when, and what product is for, and how we can further improve it. Just like answer those sort of question, and he's sort of like already like building it. And next step for ML is basically just like versionize the model. Where is the model was trained on, from what data set. So if you're looking at this graph, we have all the training data set pushed to Google BigQuery. So whenever like we're looking at certain geography, we know the data is available for certain years and for certain geolocation, and then we can quickly pull down the data. And those training data set and model should be versionized, put into the metadata, so it's going to be searchable. So it's just like going to make our like ML engineer work like so hard. I'm personally very against creating your customized tooling. I think like a lot of effort should go into like trying to make your work like more organized. Like Stack is exactly doing that. It's just like helping you to organize your items in the organization. And a lot of our work should be focused on, like doing the science and come up with new methodologies so we can better answer our question. So yeah, next, I'm super excited about the versioning model and just create a stack out of it.
I think an area where Stack can grow is better representation of like the time that labels are valid for, because whenever somebody is like annotating a label, they are looking at imagery that is like at a certain point in time. You want to track that, I think, with each individual vector that's labeled, because that can easily get lost. Folks can use vector labels like where it's like not appropriate and they're no longer relevant. And I've just seen like things are all over the place in this area. Like one of my first projects was using agricultural field data, and they didn't like tie each vector to a Landsat scene. They said, it's valid for some point in 2005. And so it was really difficult to use that data actually to train my own model. I think an area that we can grow in terms of publishing models is not just publishing like a Docker file that like runs inference with like a portable model file, but actually publishing the weights for that model as well. If you want to be truly open source and you want your work to be truly like reproducible and extendable, you need to publish the model weights so that folks can retrain your model from like a checkpoint. So that's something that folks just may forget when trying to publish their work.
Is that something that ML Hub currently supports? I mean, I thought that
I thought your weights were there. I looked yesterday, I'm pretty sure.
The weights are there?
Use the microphone,
Okay.
please.
I think it supports that, but
I'm not sure. I'm not sure about the Docker container that the model is in.
Does it support users uploading model weights?
The three models that are in MLHub currently, they are in Docker images to run inferencing, and there is the support for like a checkpoint file that's kind of part of the GitHub repo with each of those. So yes, I think so.
So would it be possible, for example, to retrieve a model out of ML Hub, save it off, and use it as a transfer point for another model?
I believe
Yeah, from the weights.
Okay.
so. You could change the checkpoint file on the file system that's actually stored outside of the Docker image. Yeah, we hope so.
I haven't actually tried that feature of ML Hub, so definitely was speaking generally. I'd love to try that out.
You got a question?
I want to draw attention to a point that Martha made about bringing in domain expertise to communicate results to various levels of technical folks. Other advice, results to different audiences, to different backgrounds, and what tools you find effective for those communities, whether they're interactive or static maps, communicating statistics in general, visuals. What have you found is more or less effective in that space?
Actually, I want to piggyback on that question because one of the curses of our profession is that we suffer from tunnel vision. A lot of the times we just get too obsessed with model performance. It's related to your questions. How do you turn a performant model into a valuable model?
I'm going to focus on. So I guess I wanted to talk about how helpful it is to have interactive map. Everyone can look at interactive maps and make their own conclusions from it, but which allows us to kind of toggle on and off different layers. And I know that there are other platforms that exist like this as well. But I think it's so helpful to be able to synthesize multiple data sets in one place and be able to see where certain outputs overlap, and then you can decision makers can make their own decisions from there. But it's also very helpful within these platforms to maybe have model cards or data cards from how those were produced, so that people can dig into those outputs and make their own determinations of if they want to use them for their decision making. But I think interactive maps are a really valuable tool.
I feel like we should be asking you how to more effectively visualize and communicate our results. But yeah, you asked specifically about statistics. They're definitely more well received when they're not in a table, when they're like graphed in some way and like compared to kind of like the current industry status quo, which is like what our research is trying to push forward, is something that's really helpful. And then we have to think about when we're communicating internally, making sure our teammates really understand, because some of them are going to go and like externally communicate to customers. So we just want to make sure like nothing is like lost in translation. There's so many excellent communicators at Trauma. We're very lucky. But the graphs are super helpful. And second, the interactive map. Those are always fun.
Yeah, I think you are the expert of the visualization. But visualization and story, I think like that's what people, it doesn't really matter what level of the user are, right? Like visual, like good visual interactive map or a good story. Like, you know, like when we were at Development C, that if you put out the GIF, that people just likes that and learn about it like quickly. Otherwise, you know, you just lost in the text and nobody read about your work.
Well, thank you. Don't we have any follow-up questions on that, I guess? No, we do have some time left. We have 5 minutes left. No? Okay. We might as well close, but I would like to pick your brain on, like, what's the big takeaway from this panel for you? what are any last messages for the audience or whoever is watching?
I think ML is really hard. Like you're looking at those graphs, and there's so many pieces come together, and it's to the company or institution or like audience, it's easier to assume like ML can do the magic, like you guys mentioned a few times, but it's just like it just want to advocate for the ML engineer is like a lot of hard work going inside it. Don't get too hype or excited about certain tooling. I think it's easier to wrap your head into a rabbit hole about tooling and methodology. Try to sit down and actually think about the science question behind the ML and what is the best approach to approach it, either like non-ML or ML, or how once you use ML, like does current like tooling going to scale up your model or not? So that's my biggest.
With this slide that's up here on it, there's so many options on this slide in order to say learn all of these options. I think my takeaway is that I hope like if you're starting like an ML project, think about like your pain and where your greatest pain points are. For me, that's and creating like an accurate, very good like annotated labeled data set efficiently. And so for me, like that's where I spend the most time like thinking about new tooling that like solves my problem. If I have the luxury, I'll spend more time on like other boxes, but think about like where your pain points are and what tooling best solves those.
Megan?
I guess for me, the biggest takeaway is it's huge that we're up on the stage communicating all the tools that we use in our various companies. It's huge that there's so many great open source tools out there that we can use in our work. For me, Stack has made it so much easier for me to focus on the fun machine learning parts because I don't have to worry about where my data files are stored in the cloud anymore. I can just refer to a Stack catalog. Yeah, I guess I just want all of us to continue like communicating what we're doing. That's been huge in our work so that we can continue to tackle the important problems that are facing all of us.
Martha?
My take-home message is that ML with satellite imagery is really powerful, and this is probably not an issue with this crowd, but make sure that you're really your time and your in the world. Like there's other applications of ML and that's cool, but like what is so greatly needed is like making a positive difference for climate change and like on the ground with humanitarian issues, and ML is so powerful, so please use your time to help humanity.
Carolyn?
Well, I would say, as far as what tools to consider, so over the last couple of days, some things have come up in this group that didn't really get mentioned in this panel. Ryan was talking yesterday about TorchGeo. And so I have found that I am not familiar with TorchGeo. I've worked with TensorFlow for using TensorFlow in our I suspect I've had to roll my own more because they just aren't there as much. So maybe if you're starting off, completely from scratch and haven't sort of gotten familiar with an ML platform yet, you might want to consider Torch. Can't speak to it myself personally, but that is how things look from where I sit. As far as tooling is concerned, I have recently been looking at 51. Not sure if y'all are familiar with 51, but it is a tool for data exploration. It has a lot of powerful capabilities. I'm currently blocked on using it because you can't view geotiffs with it. But I'm planning on basically digging in and figuring out whether that's something that I can fix easily. You might want to have a look at 51. As far as I can tell, it's pretty unique and not something I can roll my own on easily. Apart from that, data quality is everything, consistency and labeling. One thing I think is really great for communication is communicating what the level of human performance is. In other words, just what is the inter-annotator agreement on labeling a building scene that is often shockingly lower than you think it would be. So that is always a good point of comparison. Be careful about expectations. Make sure that people don't expect perfect performance out of a machine learning model. Often they do. So.
Thank you all for speaking to us. We really appreciate it.
Thanks, Freddie.